For 15 years, enterprise technology operated on a single, comforting premise. Server space was cheap, infinite, and ready, exactly when needed. If you had the budget, you could scale. But in May 2026, the illusion of the elastic cloud hit a concrete wall of physical infrastructure. Scaling enterprise software is now restricted by the physical scarcity of silicon and energy. In just 5 days, executives running the world's largest platforms admitted their supply chains were breaking. On May 1st, OpenAI's Sarah Frier declared a vertical wall of demand. They had exhausted their token supply. No amount of money could fix the bottleneck. The next day, Meta raised its capital expenditure guidance to $145 billion, openly admitting they had failed to forecast their own hardware needs and were desperately reserving future capacity. On May 3rd, Google Cloud revealed a strategic backlog of $460 billion, a number that doubled in a single quarter as terrified enterprises rushed to hoard compute tokens. By May 4th, Microsoft confirmed Azure's growth was capped by data center limits. The following day, Oracle announced Project Jupiter, moving massive operations off the public grid, relying entirely on this array of independent Bloom Energy fuel cells. The world's primary cloud providers are effectively sold out. Pay-as-you-go AI models now face the hard reality of a capped supply chain. To understand why the supply chain broke, we have to look at how AI actually operates. Initially, the focus was on model training, a massive but one-time capital expense. Today, the focus is on inference, the perpetual, real-time cost of running those models for end users. As this infographic shows, inference has quietly taken over. It now accounts for 70 to 80% of all global AI compute usage. Training requires raw computational throughput to crunch datasets, but generating each new inference token is strictly limited by latency, specifically how fast your memory bandwidth can physically move data back and forth. The true choke point sits in the memory stack. This photo highlights HBM4 and HBM4E components. A severe global shortage of this specific high-bandwidth memory has turned fabrication plants into the absolute limiters of AI output. You cannot use software optimization or larger budgets to bypass a fundamental physical shortage of this specific silicon. The second inescapable limit is electricity. A single modern AI server rack requires 10 to 20 times the electricity of a legacy IT server. Legacy public utility grids, like the high-voltage transmission network seen here, simply cannot support that localized power density. This creates a hard physical cap on where new data centers can even be built. Scaling enterprise AI has moved far beyond the realm of pure software engineering. It is now a ground war over physical real estate, sovereign power generation, and heavy infrastructure. This scarcity creates 3 immediate traps for businesses. The first is the consumption trap. Software vendors are killing flat-rate pricing and moving to consumption models, passing the extreme volatility of inference costs directly onto your corporate budget. Second is the mid-build lockout. Organizations currently building AI pipelines are assuming they can just rent the required server space later. They will soon find out their future capacity has already been hoarded by the hyperscalers. Business cases mapped out at today's current token prices will be mathematically unviable when surge pricing hits tomorrow. Soon, major consultancies will advise you to mitigate this by signing expensive, multi-year capacity reservations just to hold your place in line. Firm warning tone. Bidding for hardware futures that don't even exist yet is a trap. A standard enterprise cannot outbid trillion-dollar tech giants and hedge funds in a raw scarcity market. There is a reliable way to survive compute scarcity. It is called architectural separation, and it is a system design that moves your operations entirely outside the scarcity cycle. Instead of running massive language models across your entire pipeline, you route standard workflows through cheap, deterministic logic. The expensive probabilistic LLM inference is strictly quarantined and treated as a rare exception. This isolation protects core data extraction and validation. When token prices surge or latency throttles hit the global market, your primary operations remain unaffected. This exact methodology is formalized in the Management Consulting Operating System developed by VUDU INTELLIGENCE, seen here. It is a purpose-built framework designed to operationalize architectural separation across enterprise environments. The window to adopt this bypass is closing rapidly. If you wait for the standard consulting playbook to arrive, you will find yourself trapped at the back of a $460 billion queue, paying surge premiums for the most expensive commodity on Earth.